Good morning, class. So today we will be having a discussion on formworks, embedded pipes, and construction joints. So this is a continuation of our lecture on concrete as structural material. So for your section 4, point A, formwork design, the following are the guidelines to ensure that the formworks shall not affect the quality of your concrete. So form shall result in a final structure that conforms to shapes, lines, and dimensions of the members as required by the structural design drawing and specifications. So form shall be substantial and sufficiently tight to prevent leakage of the mortar. So when you say tight, so the formwork should be uh, enclosed in such a manner that no amount of cement mortar will pass through the forms. So, as this might affect the quality of your concrete material. So, forms shall be properly braced or tied together to maintain position and shape. So, it is a must that you properly brace and tie the forms so as to achieve conformance to shapes, lines, and dimensions of the member as stipulated on the plans. So forms and their support shall be designed so as not to damage a previously placed structure. So whenever a formwork is attached to an existing structure, it is to be observed that the existing structure will not be affected by such attachment, erection, and placement of concrete uh, during construction. So the design of formwork shall include all consideration of the factors concerning construction methodology. This refers to both the manpower and the equipment resource that are needed during the conduct of concrete pouring. So removal of form, shores, and reshoring. So form shall be removed in such a manner as not to impair safety and serviceability of the structure. So when we refer to safety, so this is something to do with the strength and serviceability, something to do with the function or use of the structure. Okay, so serviceability aspect can be broken down into several components such as deflection, cracking, funding, etc. So concrete to be exposed by form removal shall have sufficient strength not to damage by removal operation. So we have to make sure that the newly placed concrete is strong enough to resist the forces brought about by the removal process. So conduits, pipes, and sleeves of any material not harmful to concrete and within limitations of this subsection may be embedded in concrete with the approval of the engineer, provided they are not considered to replace structurally the displaced concrete. So for conduits, pipes, and sleeves, the mode of embedment have two types. So we have the embedded in type or the passing through type. So for the beam slabs and walls, it is more common to encounter the passing through type of embedment. So let's take for example that you have here a beam wherein a conduit is about to be placed on one side, passing, okay, through the beam transversely, okay, on the other side. So in this case, the diameter of the conduit should be checked, and it is permitted to embed or pass through the sleeve, provided that the diameter shall not exceed 1/3 of the thickness of the slab, wall, or beam. So if the thickness of the slab, wall, or beam is, say, 10 inches, then the allowable diameter of this conduit can now be computed on the basis of 1/3 of 10, which is 3.33 inches. For the spacing requirement, the spacing between conduits are limited to 3 times the diameter of the conduit. So if we put more than one conduit on this side, so the spacing in between the two conduits shall not be smaller than 10 inches. Okay, for columns, the embedded in type or mode is more common. So for a certain column dimension, let's say 10 by 10 inch column, so if we have a column section which is 10 by 10 inches, the diameter of the conduit shall be allowed in terms of the area of the section. Okay, so if this is your area, which is 100 square inch, then your conduit diameter shall be 5%, not more than 5% of your cross-sectional area. So this becomes now 5 square inch. So if you want to get the diameter, this is now the area of the conduit. So if you want to get the diameter, we simply make use of the formula for area of a circle, which is simply d is equal to the square root of 5 inch square divided by pi, and then multiplied by 4. Okay, so this was obtained from the formula pi d squared all over 4 is equal to the area. So for the remaining subsection 5, 6, and 7, this is all about the construction joint requirement. So for the construction joint requirement, we are referring to construction joints as two concrete masses are poured differently at different times. Okay, so when you have two mass of concrete poured at different times, then the joint in between them is called a construction joint. So in this case, the joints should always be cleaned and all the latents are removed. So the latents are simply the milky-like cementitious material that often are residues of a previously poured concrete. No? So the presence of such material can actually harm the concrete because it can affect the hydration process, and we all know that hydration is the key to achieving a very good and a very strong concrete. So all constructed joint also shall be wetted, but has to be free from standing water. So the excess amount of water can also uh, harm the strength and durability of concrete, since the excess water can form uh, later as honeycombs or voids as soon as the excess water evaporates from the mixture. So for the construction joint location, we have to deal with the proper uh, uh, locations of construction joints based on the design plans, because we are actually avoiding points of critical stresses wherein the tensile, shear, shear forces affects the concrete strength, because we know for a fact that concrete is very very weak in tension. So with that, we finish the formwork lecture, and next meeting we will be dealing with the use of steel as a structural material. So thank you for listening, and a good morning to all.